Good evening, dear students.
Good evening, sir.
Uh, nice. We'll take up D and F block from the place where we have left in the last class. Okay, we were discussing about the oxidizing properties of potassium permanganate, right? So potassium permanganate. We have seen potassium dichromate before. Potassium permanganate can act as a strong oxidizing agent in acidic medium, basic and neutral medium. Remember that neutral medium, when I say it is water, basic medium is slightly basic. Heavy alkaline medium will have a slightly different reactions. Okay, it is only slightly basic medium. Okay, mild alkaline medium otherwise. So we've seen preparations also. Okay, so oxidizing property in acidic medium, iodides to iodine, ferrous to ferric, oxalate to carbon dioxide, and sulfide to sulfur. And in basic medium, oxidizing property of alkaline of potassium permanganate in alkaline medium, the reaction would be different. In alkaline medium, when you treat, or in neutral medium, MnO4 becomes MnO2. There will be gain of 3 electron, whereas in acidic medium, you can see here the first equation, MnO4 becomes Mn2 plus, gain of 5 electrons. So the extent to which it undergoes reduction by gaining electron is more in acidic medium than in basic medium. That's why it's relatively a stronger oxidizing agent in acidic medium than in basic medium. So all these things we have concluded. And I have told you to write thiosulfate to sulfate oxidation process in alkaline medium. I have also told you to try. Sumed also gave me some answers. But how about remaining? Have you tried the thiosulfate to sulfate? Have you written? If you have done with it, give me the reaction. Give me the reaction of thiosulfate to sulfate. Not done or done? Okay.
Oxidation number will change from 2 to 2.5, sir.
No. Oh, okay, like that. Overall electron you can change. You just need to add electrons, no?
Oh, yes.
Overall electrons you can change. You take, that's all. So you people are trying now. See, first equation is common. Okay. Sumed, did you work out again?
Sir, I had done a mistake in copying the question. I wrote S2O8 instead of S2O3. There only I did wrong.
Oh, peroxosulfate you have taken.
Yes.
S2O8 is peroxosulfate. This is thiosulfate. Okay. I think you would have done correctly now.
No oxidation number will change from +6 to +2. So, +6 to +2 is 4 electrons. So you multiply first equation by 4 and second
Give me the
equation.
final equation.
Sir, can I tell final equation, sir?
Yeah, tell me.
8 MnO4 minus plus 3 H2O32 minus plus H2O gives 8 MnO2 plus 6 SO42 minus plus 2 OH minus.
That's correct. 6 sulfate you told, no?
Yes, sir.
That's correct. Good. Okay, let me try this. You pay attention, those who have not done. If you don't want to do, that's a different thing. Now we'll take up first equation is common in neutral or slightly alkaline medium. So MnO4 minus 2H2O plus 3 electrons giving rise to MnO2 plus 4OH minus. So this is the common equation. What is the next equation? It is thiosulfate to sulfate. So write this S2O3 2 minus to become sulfate SO4 2 minus. It's quite obvious that when 2 sulfur is there, it has to be converted to 2 sulfate. I told you to remember this 10 OH minus ion. Like in the previous case, iodide to iodide, 6 OH minus ion. That will help you a lot. Done. Rest it is easy. Now tell me total negative charge on the left hand side of the second equation. Total negative charge 10 OH minus plus 2 negative charge. Total negative charge on the left hand side
12.
12. Total negative charge on the right hand side, how much is there?
4.
4. How many more electrons therefore required to be added to balance the charge on left hand side?
8.
8 electrons. Correct? No. And this 3 oxygen is there in S2O3. It's been converted to SO4. How many oxygen does it take? 2 into 4. 8 oxygen is required here. 3 oxygen comes from S2O3. Remaining 5 more oxygen are required to convert S2O3 to SO4 2 minus. So 5 oxygen will be taken out from 10 OH minus. Are you understanding? 3 oxygen are there here. You want 2 into 4, 8 oxygen to form sulfate. 3 are there here. 5 will be taken out from OH minus. Remaining 5 oxygen and 10 hydrogen will form 5H2. Plus charge balancing on the left hand side 12 electron, 12 negative charges. On the right hand side 4 are there. So you can add 8 electrons. This is the most simple way to add electron. If you keep calculating oxidation number, you may be a little confused for the reason that it becomes fraction. Now, electron required for reduction process in the first reaction is 3. Liberated is 8. So we need to balance it. So crisscross. When you crisscross, equation 1 into 8, equation 2 into 3. Okay. What are the things that cancel? The electrons will get cancelled. Okay. And how many OH minus ions will be there on the left hand side of the second equation? 30 OH minus. How many OH minus ions? Oh, this I cancelled 8 itself. Into 8. Okay. How many OH minus? 30 OH minus on the left hand side of the second equation. How many OH minus ions on the right hand side of the first equation? 32. So if I cancel, how many remain? 2 remain on the right hand side. Similarly, water. 5 into 3, 15 water on the right hand side of the second equation. Whereas on the left hand side of the first equation, 8 into 2, 16. How many remain? 1. Let's write in the circle. While writing overall reaction, don't multiply that circle number again. Okay. So now anything else to cancel, you need to check once again. Nothing to cancel. So let's write now. So you can just write 8 MnO4 minus plus 3 S2O3 2 minus plus 1 H2O giving rise to 8 MnO4 to MnO2 plus 2 into 3, 6 SO4 2 minus. What remains is 2 OH minus. This is the overall. Is that okay?
Sir, at first, how will we know how many OH?
Little louder, little louder.
How will we know how many OH to add, sir?
ಅದೇ ನಾನು ಹೇಳಿದ್ದು ಏನಾಗುತ್ತೆ ಸಿ ಯು ನೀಡ್ ಟು ಗೋ ಅಕ್ರಾಸ್ ಕ್ಯಾಲ್ಕುಲೇಟಿಂಗ್ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಅಲ್ಲ ಇದನ್ನ ನೆನ್ಪಿಟ್ಕೋಬೇಕು 10 OH minus you just need to remember in this equation. That also I told you this kind of equation to remember this coefficients would happen overall some 10-12 equations in the entire syllabus. So whichever seems to be little difficult for you, better write it separately in a sheet. These kind of big equations are there only in D and F block elements, maybe to some extent in oxidation property of sulfuric acid and nitric acid in P block elements. Otherwise, rest all the equations you can somehow balance it. So if you see overall, to remember certain things, just go across these equations and write it in a separate page. Just practice it. That's all. One way also, trial and error method, you just need to say S2O3 2 minus will give 2 sulfate. Correct, no? 2 sulfate. And there are 2 into 4, 8 oxygen required, 3 oxygen here. So 5 OH minus, right? 5 OH first. Then you try to balance. Then you will happen to double the amount of OH minus. This will go by trial and error method. Otherwise. So it takes a lot of time. The key word or key thing to remember in this balancing is 10 OH minus in the second equation. Like that, 6 OH minus in the second equation of previous one. If you remember that one, just everything will be fantastic. Easy. Is that complete now?
Done, sir.
Yes, sir.
To answer this, Kishan question, okay, you can alternatively, if you want alternative methods. Kishan asked me, right? Otherwise, how like that? Is it Kishan?
Yes, sir. Me only.
Low voice is always Kishan. Okay. Now, if you calculate oxidation state of S2O3 2 minus, what will be the oxidation state of each sulfur? It will be plus 2. Each sulfur, because you can calculate 2x sulfur, 2 sulfur, minus 2 into 3 minus 6 is equal to minus 2. So 2x is equal to plus 4, x is equal to plus 2. Am I right?
Yes,
And
sir.
sulfur in sulfate is plus 6. So tell me, when each sulfur converts from plus 2 to plus 6, how many electron does it lose?
4.
Alva. So how many sulfur are there? For 2 sulfur, how many electron will be lost total?
2.
2 into 4. Each sulfur loses 4 electron. 2 sulfur loses 8 electron. So write 8 electron on the right hand side. Howda? 8 ಬರ್ಕೊಳ್ಳಿ. 8 electron ಆದ್ಮೇಲೆ you need to balance the charge. Let's say you have not written OH minus. Let's say you have not written OH minus. Plus 2 to plus 6. For 2 sulfur, it is 8 electron you have written. And now look at the balance of charge. 2 into 2, 4 negative charge plus 8 electron, 12 negative charges are there on the right hand side. But there are only 2 negative charges. How many more negative charges are required on the left hand side? 10. So 10 negative charges in basic medium come from OH minus only. So add OH minus 10. This is another way to remember. Is that okay?
Yes, sir. This is.
Aga 5 water molecule is here. See, balancing one memory, another go to the root level of oxidation number method and do it. That's all. Is it okay, Mr. Is it your question answered? Mr. Kishan Balaji. Kishan Balaji is speaking, but I'm not able to hear. Is that the thing? Ush. Okay. So this is about this thiosulfate to sulfate, iodide to iodate. Okay. I want to give two more equations in acidic medium. Sometimes it will be asked also. I looked at 4 equations of in oxidation.
sir.
Iodide to iodine we have done, ferrous to ferric, oxalate to carbon dioxide, sulfate to sulfur. In ಎರಡು ಬರ್ಕೊಳ್ಳಿ. Okay. We'll take 2 more. E. This is sulfite, SO3 2 minus to sulfate. Can you do it now? First equation is this. Give me the overall balanced equation. Let's see how many of you can do it. Sulfite to sulfate. Anybody done? So time up. Okay. First equation is common. Sulfite is getting converted to sulfate, right?
Sir, can I tell final equations?
Tell me.
Sir, 2MnO4 minus plus 3SO3 2 minus plus H2O gives 2MnO2 plus 3SO4 2 minus plus 2OH minus.
What about overall charge? Did you check total charge on the left hand and right hand is balanced?
No, sir.
Ali tappai. Check ಮಾಡಿ. Okay, let me give, pay attention here. See, SO3 2 minus has to be oxidized to sulfate, right? Write sulfate on the right hand. Tell me, this is acidic medium. There will be H plus and OH minus. There only you have to play. Either you need to convert H plus to water, water to H plus. Whereas in basic medium, OH minus to water, water to OH minus. You need to remember always like that. In basic medium, conversion of OH to water, water to OH. Here, H plus to water and vice versa. Now tell me, SO3 2 minus, if it has to become SO4 2 minus, what is to be required for oxygen requirement? What is that we need to add there?
OH minus.
OH ಎಲ್ಲಿದೆ ಇದು acidic medium appa.
Water.
I told you
Water. Sorry.
Yes. Now if one oxygen is taken out to SO3 2 minus to form SO4 2 minus, so how much H plus will be produced?
2.
Okay, 2 H plus will be produced. And how many electron needs to be added now? What is the oxidation state of sulfur in SO4 3 2 minus? Plus 6.
12.
Sorry, this is plus 4. This is plus 6. So 2 electron must be added. Plus 4 to plus 6. Correct? No? Now, come on. What I have to multiply first equation with?
2.
By 2. Second equation by 5.
5.
What are the things that will cancel? 10 electron get cancelled. 10 H plus is there on the right hand side second equation. 16 H plus. So what remains is 2. Write it in the circle. And 4 into 2, 8. And here 5. What remains is 3 H2 on the right. Let's add it now. Correct? So when you add, you will get the overall equation. 2 Mn O4 minus plus 5 SO3 2 minus plus 2 H plus giving rise to 2 Mn 2 plus 5 SO4 2 minus plus 3 3H2. Is it
Sir, shouldn't it be 6H plus?
Then what I mean. This is 10 and 6H plus, correct? I'm sorry. This has to be 6H. So ಇದು ಕೂಡ 6. It's balanced. You can even check the overall charge on the left hand side, right hand side. 5 into 2, 10, and that plus 2, 12, plus 6 positive. So it will be 6 negative on the left hand side overall. Right hand side, 5 into 2, 10, and 2 into 2 plus 4. 6 negative on the right hand side. So overall balanced. Last one you take. What is this? Can you tell me? NO2 minus 2, NO3 minus. Correct? Nitrite to nitrate. Give me the balanced equation for this nitrite to nitrate. First equation is common. Anybody has got?
Sir, can I see, sir?
What?
Sir, 5 NO2 minus plus 6H plus 2 MnO4 minus
Giving rise to
3H2O plus 5 SO4 2 minus plus 2 Mn plus 2.
5 NO3 minus.
Yes, sir. 5 NO3 minus.
But you told SO4.
Sorry, sir.
Ah.
I read the previous equation.
Oh, okay. Unfortunately, for previous equation is also 5SO4. Okay. 2 Mn plus 2. That's correct, Ms. Nutan. Good. We'll take it further. First equation is common. When I say that, let me write this equation.
Sir, how to decide if acidic medium or basic medium?
Onchur loudspeaker bekanaya.
How to decide is it acidic or basic medium, sir?
Avare kottirtarre. New decide madbekagiಲ್ಲ. They will give, okay, give the reaction of oxidation of iodide to iodine in acidic medium by potassium permanganate. How does potassium permanganate oxidize nitrite to nitrate? Give the conversion of the thiosulfate to sulfate in basic medium. They'll give like that. That is not your botheration question. Question paper will setter will be bothering.
Thank
Okay.
you,
Would you like to set a question paper?
don't have that much power.
You don't have
That much power.
power. Okay. So power. Okay, that's fine, but we'll get back to this now. Nitrite to nitrate. Okay. First equation is common. Now the second equation is about converting NO2 minus to NO3 minus. So one extra oxygen is required. It's acidic medium. From where do you get oxygen? Come on.
Water.
So how many water? One. So O2 plus 1, O3. So what should I write on the right hand side now?
2H plus.
How many more
2H.
electrons are liberated now?
2 electrons.
Calculate oxidation state. X minus 4 is equal to minus 1, X is equal to plus 3. This is plus 5. So 2 electrons are liberated out. Correct? So let us cancel the terms. Simple. Before that, 5 electron required, 2 electron liberated. Multiply equation 2 by 5. Equation 1 by 2. Okay. So similar terms cancel. 10 electron. 10 electron get cancelled. Similarly, 2 into 4, 8 water and 5 water, 3 remains. And 5 into 2, 10 H plus, 16 H plus, 6 remains. So whatever remains finally. 2 MnO4 minus plus 5 NO2 minus plus 6 H plus, giving rise to 2 Mn2 plus. Newton writing the order should be, there is no hard and fast rule like that, but generally we do like this. Important reactants first. Okay, and water, hydrogen, all such things should be at the end. Okay, so Mn2 plus and 5 NO3 minus plus 3H2. So this is about the reactions. This completes D and F block elements. Let me know if it is completed.
Done, sir.
Okay. Nikita is there. Nikita. Okay. Prajwal. Prajwal. Okay. One second, Pa. If you just can hold on for just 1 minute, go through these equations again.
Sir, Karudra.
ನೀವಿದ್ದೀರಾ ಮೇಡಮ್?
Yes, sir.
ಓಕೆ, ಇವರು ಸ್ಟಡಿ ಸರ್ಕಲ್ ಮಕ್ಕಳು ನಿಖಿತಾ ಅಂಡ್ ಆಮ್ಶು. ಅವರು
ಸರ್ ಸಾರಿ, ನಾನು ಹಾಕಿದ್ದು ಇದು ಅದಕ್ಕೆ ಹಾಕಿಲ್ಲ ಸರ್, ನೋಡ್ತೀನಿ ಸರ್ ನಾನು.
ನೀವು ಹಾಕಿದ್ದೀರಾ, ಬಟ್ ನಾನು ಹಾಕಿದೆ, ನಾನು ಮತ್ತೆ ಲೇಟ್ ಆಯ್ತು ಸ್ವಲ್ಪ.
ಫೋನ್ ಮಾಡಿ ನೋಡ್ತೀನಿ ಸರ್ ನಾನು ಇವಾಗ.
ಅವ್ರು ಬಂದಿಲ್ಲ, ಒಂಚೂರು ನೋಡ್ರಿ.
ನೋಡ್ತೀನಿ ಸರ್.
Okay, students. So this is about KMnO4. When you take the application of KMnO4, this KMnO4 acts as a strong oxidizing agent, and also KMnO4 is used to detect the position of unsaturation. You know, unsaturation test in organic chemistry. Take the compound, add KMnO4, which is also called Bayer's reagent. If pink color disappears, the compound is unsaturated. If pink color remains, the compound is saturated level. And also it can be antiseptic lotion also. KMnO4 dilute can be used to wash the wounds also. Okay, in the lab, by any chance, if you have kind of hurt or cut that happens to the skin, you can wash it with KMnO4 dilute, or even hydrogen peroxide will be there in the lab, either that or this. Okay, it acts as an antiseptic and disinfectant in a higher concentration, you can say that. Okay, so this is about KMnO4. There is one thing we need to know. Generally, KMnO4, whenever it is used in acid medium, okay, all these reactions are in acid medium. The acid medium means what? You are going to treat or dissolve KMnO4 in a dilute acid. Okay. So which acid would you recommend? The acid medium for KMnO4. If KMnO4 is used in acid medium for oxidation process, which acid medium would you recommend? A, HCl, B, H2SO4. Dilute HCl or dilute H2SO4, which one would you recommend? Or both?
Dilute H2SO4.
Pardon me?
Dilute H2SO4.
Why? Why not HCl? You don't like HCl?
Sir, for a second I thought it was K2Cr2.
In K2Cr2 also you can, again, sulfuric acid is used. HCl also can be to some extent. Again, that threat is there in potassium dichromate also. Okay, be it potassium dichromate or KMnO4, why not HCl? Anybody? Okay, I'll give you a choice. See, acid medium for KMnO4 is generally dilute H2SO4. Okay, dilute H2SO4 only will be used, not HCl. Now, can you think about the reason? I'll give you a hint. KMnO4 is an oxidizing agent. That's all the connection.
Sir, the Cl minus have high chance to react.
What would happen?
To react with the reactant.
Sir, we will get KCl plus MnCl2 plus H2O plus Cl2.
That means HCl reacts with KMnO4.
Yes, sir.
What it becomes?
Sir, we will get potassium chloride and magnesium chloride, manganese chloride.
Adu barli HCl the medium itself react agutte anta heladu. Why not HCl andre? HCl reacts. What happens to HCl is what is important. Bered fine, bered bande barutte. So HCl will be oxidized by KMnO4, and where you get Cl minus. That means Cl2. Cl minus get converted to Cl. And of course, manganese chloride and potassium chloride, all those things will come. But here, medium, you are going to react KMnO4 and oxidize some other reactant in acid medium, right? The acid medium, the solvent itself starts reacting, where HCl gets converted to chlorine. You want KMnO4 to oxidize some other substance, but HCl only starts getting oxidized. So therefore, this is not a good choice. Why not H2SO4 gets oxidized with KMnO4? Correct, no? If HCl reacts and gets oxidized with KMnO4 to Cl2, H2SO4 also should be oxidized, no? No idea?
SO4 will not react.
Why?
It's bulky.
SRP value is this.
Little louder.
In electrochemical series, SO4 is placed below Cl.
It's not about Cl or H2O4 minus. It is about Mn and SO4, right? When you use KMnO4 and H2SO4, how exactly things happen? Now, KMnO4 is an oxidizing agent. In H2SO4, sulfur is in maximum oxidation state of +6. Look at this. Highest oxidation state of sulfur is plus 6. So in H2SO4, sulfur is in highest oxidation state. Therefore, it can't be further oxidized. Okay, that's why you can't. Whereas KMnO4 can't be taken in sulfurous acid. Sulfurous acid is H2SO3 because here it is plus 4. If you take KMnO4 in sulfurous acid medium, it may be get converted to H2SO4 oxidized. So it is not possible to take this like that. So H2SO4 is best medium for the reason that sulfur is in highest oxidation state. It can't be further oxidized. Is that clear now?
Yes, sir.
Yes, sir.
Okay. So this is about D block elements. We'll go to F block elements. F block elements, not as much as D block elements. There is only little briefing about certain properties, and importantly, we need to study something about atomic size variation, which is in concern with lanthanide and actinide contraction property. Okay. So next is F block elements. Okay. See, to start with F block elements definition and everything I have given you in the beginning itself. F block elements are those where electrons are added. The differential electron or the last electron enters into pre-penultimate or anti-penultimate F orbital like that. Correct? That is F block elements. What is the general electronic configuration? So it is ns2 n-1 d 0 to 1, not 1 to 10, either 1 or no electron. Actually, F block element means F orbitals must only fill, but in some elements D also will have 1 or 0 electron. Okay, something. And there are two things, lanthanides and actinides. Lanthanides or lanthanoids, like that we say. Actinides. So lanthanides are 14 elements which are kept after lanthanum. Correct now? Lanthanum, atomic number 57. Correct? And actinides are 14 elements which are kept after actinium. This is 6th period, 7th period. So lanthanides are from 6th period, actinides are from 7th period of the periodic table actually. So after lanthanum, it is cerium to lutetium. Okay, cerium to lutetium. Cerium is atomic number 58. After lanthanum, it is 58. You can add 14 to 57. Then what do you get? 71. Atomic number of lutetium is 71. After lutetium, this will be zirconium. This is hafnium. Hafnium. Atomic number 72. Like that. Similarly, actinides are the set of 14 elements which are placed after actinium. Actinium atomic number is 89. And this is thorium. Atomic number 90. Lawrencium. You can add 89 plus 14, 103. And after lawrencium, it is Rutherfordium, RF. And this is atomic number 104. And it proceeds with D block. So between lanthanum and hafnium, there is 14 elements. Similarly, between actinium and Rutherfordium, there is 14 elements. Okay. Vallabh has entered now.
ಎಸ್ ಸರ್ ಈಗ ಬಂದ್ವಲ್ಲ ಬ್ರೋ.
ಯಾಕೆ?
Sorry, sir, network issue. I was trying from long time.
ಹೌದಾ? Okay.
It's like near here or here, there is some wiring connection
ಹೌದಾ?
is going on. So that
Is it? Okay. How about Nikita? Nikita is not at come.
ಸರ್ ನಿಖಿತ್ ಡಾಟ್ ಕಾಮ್ ಸರ್ ಅದು ಟ್ರೈ ಮಾಡ್ತಾ ಇದ್ದಾನೆ ಪ್ರಜ್ವಲ್. ಅದು ಪ್ರಜ್ವಲ್ ಹತ್ರ ಇದೆ ನಂಬರ್ಸ್ ಎಲ್ಲ. ಸೊ ಈಸ್ ಟ್ರೈಂಗ್ ಸರ್.
I am sure.
ಐ ಟೋಲ್ಡ್ ಹಿಮ್ ಟು ಕಾಲ್
Okay.
ಹಿಮ್ ಸರ್.
Okay. Right. Now coming to this lanthanides and actinides. So from lanthanum to hafnium, 14 elements gap is there. Lanthanides are set of 14 elements which are kept after lanthanum from cerium to lutetium, in which is the f orbital that fills 4f 1 to 14. Okay. So actinides are the set of 14 elements which are kept after actinium, in which 5f 1 to 14 is filled. 5f. Okay. So this is the thing. And one homework, this I can do. Simply if I keep writing electronic configuration, you will also copy down. I want you to take it as an assignment. Just write this table. Okay. So this is lanthanide element, atomic number, electronic configuration. Lanthanides atomic number start from 58, no? So inner core will be similar to nearest noble gas, that is xenon. Xenon is 54. So after xenon, it is 5d, 4f and 6s that will fill, correct? 6s, 4f, 5d. This is the order. Okay. You need to write this lanthanides. So xenon will be inner core electrons. Okay. Like that, actinides elements, atomic number and electronic configuration. Actinides atomic number starts with 90, thorium. So nearest noble gas with which you can refer to inner core electron is radon. Radon is 86. Xenon is 54. Correct? For example, if you want to write cerium, atomic number is 58. Xenon 54. How many more electrons? It is 4 more electrons. What is the order? After that, 6s, because lanthanides will have 6 shells. 6s, 4f, 5d. This is the order. Correct? Now you need to add 4 more electron to make it 58. So that 2 electron will go to this. After that, remaining 2 electrons have to go to F actually. Am I right? So 1 electron go to F and 1 electron go to D. So you just count all the elements of lanthanides and actinides. Wherever electrons are added to D orbital also, you just know about it. They can be considered as something exceptional electronic configurations. Why? Because F block elements are those where differential electron must go to only F. If any F block element has electrons entering into D also along with F, then you just remember them. Those can be considered as the deviation from regular electronic configuration. And you need to remember only those exceptions, because remaining will follow normal electronic configuration tendency. So cerium is one such element. Okay. For example, next one is prasodium, we say. Next one is prasodium. Prasodium is atomic number 59. How would you think the electronic configuration? Xenon 54. And remaining, how many more electrons? 5 electrons. So with the orbitals available are 4f, 5d and 6s. Actually, strictly speaking, F block element should not have electrons into 5d. But exceptional electronic configuration like cerium will have. In case of prasodium, 2 electrons go here. Now 54 plus 2 is 56. Remaining 3 electrons enter into 4. And this is 0. That's why the general electronic configuration of F block is n minus 1d 0 to 1. Some elements will have one electron, some elements wouldn't have electron. If d orbitals are not filled in F block element, then it can be normal electronic configuration. So remember only those elements which deviate from the regular electronic configuration, meaning whichever elements of lanthanides or actinides that possess d electrons also along with F should be considered as exception, and remember separate. If you count how many elements are there having d electrons also along with F electron, 3 elements of lanthanides and 6 elements of actinides possess d electrons along with F. So 6 plus 3, totally 9 elements you need to write and practice. And remember that they have 1 electron in d along with F. Rest all the elements will have regular electronic configuration. You need not have to remember. If you remember, that's fantastic. If you think it is really hard to remember, then remember only these 3 plus 6, 9 elements which will have electron in d orbital. Rest will have regular electronic configuration. That means no d electron. Electrons enter 6s, after that 4f. Like that in actinides, 7s after 5f. So let me write one thorium here. Thorium is Th for first element of actinides. Okay. Let me use a different.
Till what element we should learn, sir? In periodic
It's
table.
better if you remember all the elements. Always, more you know, it is always good for you. But sometimes, memory, it may be hard. Okay, remembering the elements. That too, these names of F block elements are quite unfamiliar for the reason that we don't use regularly. If it is carbon, nitrogen, oxygen, fluorine, bromine, iodine, so that's fine. But here, these are all very rarely used elements. If you practice 14 plus 14, 28 elements, it is not definitely impossible. It will be easy, but at least these 9 elements, 3 plus 3, exceptional electronic configuration, if you remember, because they are exception, they have d electron also. Rest elements you can, even if you don't know, when atomic number is given, you will be able to write it. You know the 9 elements, any other elements, if it is given with atomic number, you will be able to write the electronic configuration because they don't have d electron. Like, okay. Now thorium is atomic number 90. When it comes to that, so inner core electron is similar to radon. So 86. How many more electron need to be added? 4 more. Which are the available orbitals? If you see, it is 7s. After 7s, actually it is 5f. But there can be chances that d also can have 1 electron. So first you add 2 here. Okay, 7s2, and then comes 2 more electron, right? That will go to the d electrons. Okay. Now thorium is a double exception for the reason that though thorium starts with atomic number 90, for 7s2 and 6d2 and 5f0 here. So put a double star. Okay. Oh, what about next one? Next one is called protactinium, Pa. It is atomic number 91. Okay. This is radon, 86. Orbitals are 4f, 6d, 7s. Alva? Now 2 electron, naturally it will go to first 7s. So 86 plus 2, 88. How many more electron? 3 more electron must be added. What do you think? Now thorium has 2 electron in d. How would it go? Is it 4f or 6d? All those things, question will arise. So you have to remember 2 electron will go here, 1 electron will go. Again, this is an exception. Is that okay? So like that, there are totally 6 elements which will possess electrons in d. So if you remember all those 6 elements, remaining elements you have to remember for the reason that they doesn't have d electron. Exceptions only you remember. Like that. Is that okay? So fine. This exercise, you need to do it with the hints that I have given here, with that background, and show me in the next class. You have to all I switch on camera and whomever I am going to ask, you have to take. Okay. So write lanthanide and actinide contraction, keeping these points in the mind, and mark all those elements with a star, whichever have unpaired electrons in D also. Okay, fine. So let us proceed further.
That there is no reason for exception.
Exception ge especially D and F block elements ಅಲ್ಲಿ general ಆಗಿ ಕೆಲವು ಪಾಯಿಂಟ್ಸ್ ಹೇಳ್ಬೋದು. One is hydration energy. Wherever ionic size is small, hydration energy will be more. Though there is half filled and completely filled orbital, it is more stable. Sometimes due to some other factor, stability acquired will be more in exceptional electronic configuration. So there are certain reasons to stabilize the exceptional electronic configuration, like hydration energy, high polarizing power, more charge and less size, what we say, high polarizing power. So these aspects will play. See, this entire actinides, they are all radioactive elements. So from thorium to lawrencium, all are radioactive elements. That's why it is not much explored part of periodic table. Be it general properties, we only simply say, for example, color. Color is because of DD transition in D block elements. We expect the similar thing, FF transition in F block elements also, but how exactly things happen are not clear yet, because they're all transition. The actinides is entire thing is radioactive elements, and also they are rare earths. For various reasons, it is less explored part of periodic table. Okay, so generally we can say some of the reasons like hydration energy, high polarizing power could stabilize the ion in that exceptional electronic configuration. Is that okay? Similar reasons we have given for Cu2 plus ion. Cu2 plus ion is more stable when compared to Cu plus ion, for the reason that Cu2 plus is small compared to Cu plus. Correct? Cu2 plus has 3d9 4s0, partially filled d orbital, yet it is more stable. Whereas copper plus cuprous 3d10 4s1 4s0, 3d10 4s0 is more stable. Half filled and completely filled is more stable. But still Cu2 plus is more stable for the reason that its size is small, polarizing power is more. So in aqueous medium, it gets stabilized due to high hydration energy, we say. Similar things can be expected for stability of these exceptional electronic configurations. Okay. So shall we proceed now? Now, so this, when it comes to electronic configuration, so next class, I should see, you should also pay attention to the details. That is important. Okay. Okay, you pay attention to these exceptions and write down once, twice, thrice, 5 times. It will be familiar, then it will be better. Okay, we shall proceed further. After this electronic configuration, second property is the variation of atomic and ionic radii. Variation of atomic and ionic radii. Here we are going to consider lanthanide and actinide contraction, which is most important under F block. Okay, so generally if F block element questions there in the examination, it will be most probably about minimum question will be there on lanthanide and actinide contraction. So what is lanthanide actinide contraction? What is its repercussion on the properties of D block elements and F block element? Let's see now. Okay, now atomic radii distance from the center of the nucleus to the outermost shell of electron is what is the atomic radii. So when number of shells increase, atomic radii increases, otherwise decreases, and atomic size will be affected by some of the factors. So can you tell me, as we have discussed before in 3D series elements, which are the important factors that will affect atomic size or atomic radius? No factor will affect atomic radius, or what is that? Your silence.
Ionization enthalpy.
Oh, no. Ionization enthalpy in turn affecting will be affected by atomic size. Ionization enthalpy is a result of atomic size. Neeti Gandhi says effective nuclear charge. Okay, number 1. Effective nuclear charge. Number 2.
Number of electrons, sir.
I don't know what has happened. I'm not able to open the chat only. The chat is not opening. Somebody has given the answer here, right? Okay, those who have given me the answer in the chat, I'm not able to open this. It's not opening up. I don't know what is the reason. Please answer, unmute and answer. Now, one more factor. We have given there in 3D series. One more factor we have discussed there. Horrible, I say. What is that we have given reason here? Scandium to chromium, atomic size decreases. Chromium to copper, it remains constant. Then copper to zinc, it increases. What is that we have given? Saka, class Saka. Shall I stop at this stage? Somebody spoke far away from the mic. I couldn't hear. Oh God.
I didn't understand the question. Could you repeat it?
The factors that will affect the atomic radius, I'm asking. One is effective nuclear charge. Other one?
Shielding effect.
Shielding effect.
Tell me if effective nuclear charge increases.
Atomic size decrease.
Atomic size decreases. If shielding effect increases. Atomic size?
Increases.
Increases. Now, what is the reason for shielding effect? See, especially in case of D and F block elements, as we move from left to right in the period, atomic number of the elements increases. Correct, no? As you move from cerium to lutetium, thorium to lawrencium, like that even in D block elements, from scandium to zinc, electrons enter not to the valence shell, instead they enter into the inner shells. In D block elements, they enter to last but one shell, that is penultimate shell. And in F block elements, they enter to n-2, that is pre-penultimate or anti-penultimate F orbitals. Whenever electrons enter into inner shells, the number of electrons, as inner electrons keep increasing, the influence of nucleus on the outermost electron decreases. When influence of the electron on the outermost shells decrease, electrons move away from the nucleus. This is called shielding effect. So as shielding effect increases, you can simply say influence of nucleus on the outermost electron decreases, because inner electron, as it increases, they shield or screen the influence of nucleus on the outermost electron. Okay. Now tell me, from left to right in lanthanides or actinides, electrons enter into pre-penultimate 4f orbitals and 5f orbital respectively in lanthanides and actinides. So as electrons are filled into inner shells, pre-penultimate 4f and f orbitals, 5f orbitals, the shielding effect must increase or decrease.
Increase.
Increase or decrease?
Increase.
See, when you say lanthanides, nucleus, first shell, second shell, third, fourth, fifth, and sixth. Okay. That blue is fourth. Now in lanthanides, from cerium to lutetium, which is the orbital that fills? It is 4f1 to 14 that fills. For lanthanides, there are 6 shells. 1, 2, 3, 4, 5, and 6 shells. Sixth shell is valence shell. Fifth shell is penultimate shell. Correct? And fourth shell is antepenultimate shell, or pre-penultimate shell. So in lanthanides, electron enter into 4f1 to 14 means electrons will be added to inner shells, that to antepenultimate shell. So when we move from cerium to lutetium, okay, electrons enter into 4f. Shielding effect should increase or decrease? As inner electrons increase, they shield the influence of nucleus, so that outermost electrons experience less attractive force. There is 6s electron here. So when we move from cerium to lutetium, electrons enter into pre-penultimate f orbitals. So shielding effect must increase. If shielding effect increases, effect must increase. If shielding effect increases, what happens to atomic size? Increase or decreases?
Increases.
Increases.
It should increase, right? But this doesn't happen. Atomic size decreases. And it's been found from cerium to lutetium, around 0.22 Armstrong of radius, atomic radius would have been reduced. Okay, so 0.2 angstrom, radius. Of 0.22 angstrom decreases from, finally you can take from even lanthanum to lutetium. Okay, it's like from lanthanum to lutetium, if you measure, overall atomic size would have been reduced by 0.22 angstrom. So what is that expected? Electrons must enter into pre-penultimate f orbital from cerium to lutetium in lanthanides. Shielding effect should increase. So atomic size must increase. But on the other hand, atomic size is actually decreased, and there is overall decrease of 0.22 angstrom from lanthanum to lutetium when it is measured. This total decrease in the atomic size from lanthanum to lutetium is what is lanthanide contraction. It's called lanthanide contraction. Okay, ಈಗ see students, ನೀವು ರೆಸ್ಪಾಂಡ್ ಮಾಡದೇ ಇರೋದಕ್ಕೆ ನನಗೆ ಕಾರಣ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. I am not able to understand. Let me pause this recording. I don't want you to see this again in the recording.